Okay, today we're going to be talking about vectors, and one of the more common applications of vectors involves velocity. And so let's say we have an object that starts here and is trying to go here, and it goes in a straight line. We can break that velocity down into its horizontal velocity and its vertical velocity, and what we'll do is we'll make a vector. So let's say an object is traveling at 5 miles per hour, and let's say that this side is 3 and this side is 4. Well, that vector's velocity is going to be 3 miles per hour in the x direction and 4 miles per hour in the y direction, and that is the particle's vector. So on this first slide you have several different equations that you will need to use for vectors. You've got the position vector, and then of course we know that the derivative of the position is the velocity, and then the derivative of the velocity, or the second derivative of the position, is the acceleration. But now we're also throwing a couple other things at you here, that if you're looking for the speed of the particle, which would simply be the hypotenuse, then you would want to use the Pythagorean theorem and take the x velocity squared plus the y velocity squared and square root them, and you will get the speed of the particle. Finally, if you want to find the length that the particle went, the arc length, then you're going to use this formula right here, which is the integral from a to b, the square root of dx dt squared plus dy dt squared, and that will give you the total distance traveled by the particle between the times a and b. Okay, we are given the position of the particle at any time t. We are able to figure out the x and y coordinates of this particle moving. And so what we want to do is we want to find the velocity vector when t is equal to 1. And as we mentioned, basically what that is how fast in the x direction is the particle moving, and how fast specifically in the y direction is the particle moving. Instead of just simply finding the exact speed, we're finding the components of the speed of the object in the x and y direction. So let's see if we can put this all together here. The velocity is the derivative of the position, so therefore the velocity vector is simply going to be 3t squared plus 8t, comma 4t cubed minus 3t squared, and we want to plug in the time t equals 1, and so when we plug in 1, we're simply going to get 11, and then we're going to get 1. And so the velocity is 11, let's just say, meters per second in the x direction and 1 meters per second in the y direction. Now it wants us to find the acceleration. Well, once again, this is pretty simple. The acceleration is the derivative of the velocity. So the acceleration, so maybe we'll call this one v of t, all right, and we'll call a of t, acceleration, equal to this vector, so it'll be 6t plus 8, and then 12t squared minus 6t. And now we're going to plug in 2. And so our acceleration at time 2 is going to be, let's see, 2 times 6 is 12, so 20. And then 2 squared is 4 times 12 is 48 minus 12, that's going to be 36. And that is the acceleration vector. Alright, similar to the last problem, now we are asked to find the magnitude of the velocity vector. Well, anytime you see the word magnitude, I want you to think of Pythagorean theorem. I want you to think of the hypotenuse. So Pythagorean theorem, I want you to think of the hypotenuse, all right, of a right triangle all of those things are going to be magnitude. So we're actually looking for the speed. All right, so let's just put that down as well. We're looking for how fast this thing goes. So when you leave your house, you do not say, I'm going 35 miles an hour north and 32 miles an hour east. You don't report your speed in terms of north and east, and you just say, I'm going this fast. And that's what we're after in this problem here. And so we are going to get the velocity vector, and the velocity vector is going to be 2t plus 3, and comma 3t squared minus 6t. All right, and then we want to plug in 1. So our velocity when time is 1 is going to be 5 and negative 3. But that is the x and y components. And so in order to get the magnitude, we have to do the Pythagorean theorem. So the speed of the object is simply going to be the square root of dx dt squared plus dy dt squared. So 5 squared plus negative 3 squared. And that is going to end up being root 34. And that is how fast the object is traveling. All right, in this problem we are given the parametric equations for the position of the function x and y. And it says time is going to be between 0 and 2 pi. And the path of the particle intersects the x-axis twice. And so therefore we need to find the two x-intercepts. And so we know that an x-intercept occurs when y equals 0. All right, so that's when you'll have an x-intercept. So we need to set the y equation, y equals 1 minus 2 sine of t. We need to set that equal to 0. All right, so sine of t is going to equal 1/2. And so when we think about the unit circle, this is going to occur at two angles, one in the first quadrant, which is pi over 6, and the other is 5 pi over 6. And so what we want to do is we want to, notice it says we want to find an expression, do not evaluate, that represents the distance traveled by the particle between the two x-intercepts. And so our arc length in parametric mode is going to be the integral from pi over 6, the first x-intercept, to 5 pi over 6, the second x-intercept, and that's going to be the square root, once again, of dx dt squared plus dy dt squared. So dx dt, we actually did not figure that out, so let's do that. So x prime of t is going to be the derivative of root 3 minus 4 cosine of t. And so the derivative of cosine is negative sine, so that's going to give us a 4 sine of t. And then y prime of t is going to give us negative 2 cosine of t. All right, so we're going to plug those into our arc length formula. And x prime of t squared is going to be 16 sine squared of t plus y prime t squared. That's going to end up being negative 2 times negative 2. You square that's going to be 4 cosine squared of t. And it looks like we can factor out a 4 from those two terms. And so it's going to be the square root of 4 parentheses 4 sine squared of t plus cosine squared of t. and the 4 can come out of the square root as a 2. And so all they're asking us to do here is set it up. So it's going to be 2 integral from pi over 6 to 5 pi over 6, the square root of 4 sine squared t plus cosine squared of t. And I probably should have made those t's capitalized so that we don't get them confused with plus signs. So that is the integral that you want to have set up for this problem. Alright, in this problem we are once again given the x of t and the y of t, the position of the particle, and it says for what values of t is the particle at rest. Well, let's just make sure we understand this. This means that the velocity vector must be 0, 0. It can't be one of the terms being 0 and the other term not being 0, because as long as either the x or y velocity is not 0, that means the particle is still moving in one direction. It's either moving north and south or east and west and still not at rest. So it needs to be 0, 0. So what we need to do is we need to take the derivative of the x of t and the y of t and set them both equal to 0 and see at what times they are both equal to 0. So we're going to first start off with x prime of t. And that's going to be 6t squared minus 30t plus 36. And then we're going to do the same thing with the y. So y prime of t is going to equal 3t squared minus 6t. And so we can factor the first one by always look to see if you can factor out something from these terms. And we can factor out a 6. So we factor out a 6 and we get t squared minus 5t plus 6. And we set that equal to 0. And we end up getting 6 and then t minus 3 and then t minus 2. So the two times when the x velocity is 0 is going to be t equals 3 and t equals 2. So we'll hold off on those and we're going to solve over here the y prime of t. And so we're going to factor out a 3t right there. And that is going to leave us with t minus 2. So t equals 0 and t equals 2. Alright, so now we look at this and we say, okay, at t equals 2, both the x and the y velocities are 0, so therefore at time t equals 2 would be when the particle is at rest. Alright, this next problem is indeed a fundamental theorem of calculus part 1 problem, although when you read it, it doesn't jump out at you that that's what you have to do. So it says a particle moves in the xy plane in such a way that its velocity vector is 3t squared minus 4t and 8t cubed plus 5. It gives you the position of the object at time 0. It says it's at 7, negative 4. Then it says find the position of the particle at t equals 1. So let's think about this. We are given the velocity vector and we are trying to find the position vector essentially. So that means we're going to have to integrate velocity in order to get back to the position. So we're going to integrate, and what do you think the two times we're going to integrate from? Well, it says t equals 0 they give us, and t equals 1 is what we're looking for. So we are going to integrate from 0 to 1 of x prime of t dt. And this is just reviewing the fundamental theorem of calculus. So that's going to get you back to the original function evaluated at the upper limit minus the lower limit. So we're going to integrate x prime of t, and that is going to give us t cubed minus minus 2t squared. All right, and that is going to be equaling the position of the x coordinate at 1, which we don't know, minus the position of the object's x coordinate at time 0, which we do know, which is 7. Okay, and over here we forgot to integrate with respect to, actually we need to plug in our upper and lower limit. So if we plug in 1 for our time, we are going to get 1 minus 2, which is -1. And then you plug in 0, you don't get anything. So then x of 1 minus 7, and then we're going to add 7 to both sides. So the particle at time 1 has an x-coordinate of 6. Okay, so we're going to do the exact same thing now with the y-coordinate. So the y function is going to be, once again, the same thing, the integral from 0 to 1 of y prime of t dt should get us back to y at 1 minus y of 0. So integrating y prime of t is going to give us 2t to the 4th, 2t to the 4th, and then integrating 5 just gets you 5t, and that's going to be evaluated from 0 to 1. So when you plug in 1, you get 7. Plug in 0, don't get anything. And then y coordinate at 1 is -4. Excuse me, that's what we're looking for. So we need to erase that. So we're looking for y of 1. And y of 0 is given to us at -4. So minus a -4. And so a minus and a minus are going to turn into pluses. And then we're going to subtract the 4. And so y at time 1 is going to be 3. And so the vector, the position of the particle at time 1 is simply going to be 6, 3. Alright, here's a calculator problem, and we are asked to find the equation of the tangent line to the curve at the point where t equals 2. And so, once again, we've seen this 100 times this year. In order to write a tangent line, we need two things. We need the point, and we need the slope. Well, they give us the point. The point is 7, 4. And so now we need to find the slope. And this is where we're going to need our calculator. So we need to make sure first and foremost that it is in radian mode. And then you're going to plug in time 2. So essentially we need the slope. So remember, dy dx is equal to dy dt over dx dt. Alright, and they give us dy dt, that's just cosine of t squared, and then dx dt is sine of t cubed. Now be careful that you don't try to do anything funny here and make it into cotangent just because you have cosine over sine. The problem is that these two exponents are not the same, so you can't combine them. So you just basically have to plug in t equals 2. So you're going to have cosine of 4 in your calculator over sine of 8. And that's going to give us a slope of -0.6601. Alright, and then we write our tangent line equation. So y minus the y coordinate of 4 is equal to the slope -0.6601 times x minus 7. There's your tangent line. All right, part B, the speed of the vector at time t equals 2. Well, we know speed is just simply the square root of x prime of t squared plus y prime of t squared. All right, and so all we need to do is find x prime of t at time t equals 2. So that is going to be, so x prime of 2 is going to be 0.989. And then y prime of 2 is going to be negative 0.65. All right, and then you throw those into our little formula for speed. And speed is equal to the square root of those things squared. So x prime of 2 squared plus y prime of 2 squared. And that is going to equal 1.186. All right, part C. For what value of t between 0 and 1 does the tangent line to this curve have a slope of 4? Well, you can see what we need to do here. We need to set dy dx equal to 4 and figure out the time. So dy dx, once again, is cosine of t squared over sine of t cubed. And we want to set that equal to 4. We want to use our calculator, and I would suggest using your solver feature on your calculator, on your TI Inspire if you have that. If not, if you have a TI 89 or 84, you're going to have to graph this and find the intersection. All right, so you're going to find the intersection between the left curve and the right curve. Either way, you're going to get a time that is approximately 0.616. And then it says find the acceleration vector at this time. So once again, here is a great opportunity for you to use your calculator. In class, I'll show you a little bit more about this, but essentially all you need to do is you need to set up the derivative and plug in at a point. So there's a feature on your calculator that under the calculus menu that you can select derivative at a point. And that's what you want to do. You want to take the derivative of the position function derivative of the velocity function to get the acceleration vector, and you will get an acceleration vector of 1.109 and negative 0.46 when you plug in t is equal to 0.616. Alright, it says find the position of the particle at time t equals 1. So obviously we know we need to integrate the velocity vector to get backwards to the position. And so they gave us in part A the fact that at t equals 2, when time is equal to 2, the position of the particle is 7, 4. Alright, 7, 4. So this one's similar to the one we saw earlier. We're going to integrate from 1 to 2. 1 because that's the time that we're trying to find, and 2 because that is the time that they give us. And so we're going to start with the x coordinate. So we're going to integrate x prime of t dt, and that's going to equal x of 2 minus x of 1. And if we integrate from 1 to 2, obviously we can't use regular traditional methods to integrate this, so we're going to have to use our calculator. So we're going to let our calculator integrate from 1 to 2 x prime of t, which is going to be the cosine of t squared function dt. Alright, and that's going to equal the x coordinate at 2, which is 7, minus the x coordinate at 1, which we don't know. When you integrate on your calculator in radian mode from 1 to 2 cosine of t squared, you're going to get 0.218 equals 7 minus x of 1. And move some things around and you will get the x coordinate at time 1 to be 6.78. All right, now we're going to do the exact same thing with the y's. We're going to integrate from 1 to 2. Y prime of t, and y prime of t is sine of t cubed. And that's going to equal the y value at 2, which is 4, minus the y value at 1, which we're looking for. And you integrate from 1 to 2 of sine of t cubed, and you will get negative 0.443. And that's equal to 4 minus y of 1. And then we move some things around again, and you get y of 1 is equal to 4.44. And so the position of this particle at 1 second is going to be 6.78, comma 4.44. And that is the answer to this problem.